Okay, this is section 2.3, and it's talking about the current accepted atomic structure. So the atom has three basic parts. Protons, which is in the side of the nucleus and has a positive charge, and is about 1,800 times the mass of that of an electron. The number of protons is the atomic number, and that is the identifier for the atom. Okay, so it's a characteristic number of the atom. And then you have an element that is substances that all the atoms inside have the same atomic number, which is also the same number of protons. Okay. You also have neutrons inside the nucleus. They are inside the nucleus and they have no charge, but they have about the same mass as that of a proton. So this structure right here on the video, above the video, is showing atomic structure. And so my nucleus is this ball of mass, if you will, inside in the center part of the atom. Okay, the blue balls here are supposed to be the neutrons, and the red balls here are the protons with the positive charge. And when I add the protons and the neutrons together, I get the mass number of that atom. Okay, and then on the outside of this, I don't have this definition on here. On the outside of the atom, or the nucleus, is the electrons. Okay, and so the electrons are orbiting around the nucleus, and somewhat like a planet orbits the sun, but not exactly. Okay, which we'll get to much later this chapter or this semester. So a nuclide is an atom that's defined by the atomic number and its atomic mass. Okay, so for example, carbon-12. Okay, so a nuclide is got both the mass number and typically the atomic symbol. Sometimes you will see the atomic number also written here. Okay, not always. So you have carbon-12. Carbon-12 has 6 protons. I know it has 6 protons because when I look at a periodic table, carbon is element number 6. So that 6 protons means carbon. And basically 12 minus the 6 gives me 6 neutrons. So this is the mass number. So you get the number of the neutrons. So you get the atomic symbol, or get the protons from the atomic symbol, or vice versa. If I have the number of protons, I get the atomic symbol. And then I get the neutrons by taking the mass number minus the number of protons and that. So when I have the nuclide C13 or carbon-13, it's still carbon, so it still has 6 protons. So the fact that both of these have 6 protons means they're the same element. But this time when I take 13 minus 6, I end up with 7 neutrons. So the number of neutrons is the mass number minus the atomic number. And so this is showing different ways of looking at it. Okay, this is the atomic number, that's the mass number, and the atomic symbol. This is carbon-12 here, has 6 protons, 6 neutrons, and a neutral atom is going to have 6 electrons. This is the carbon-13, I still have 6 protons, 7 neutrons, and again, it's a neutral atom, so it's going to have 6 electrons there. So isotopes are atoms of the same element, but they have the same atomic number, same number of protons, but they have different mass numbers. So what I showed you before here with carbon, these are 2 isotopes of each other, carbon-12 and carbon-13. Hydrogen has 3 isotopes. It has hydrogen-1, which means it has 1 proton and 1 neutron. So the mass number and the number of protons is the same because there's no neutrons there. There's deuterium that has 1 proton and 1 neutron, so my mass number now becomes 2. It still has 1 electron, 1 proton. So the 1 proton means that it's hydrogen. And then there's tritium, okay, which is 1 proton, making it hydrogen. And this one has 2 neutrons here, so it gives me a mass number of 3. So the proton's 1 for all of these because they're all hydrogen. That's why a lot of times the atomic number is not written, because it's kind of repetitive to say the fact it's got hydrogen and it has 1 proton. The fact it's hydrogen means it has 1 proton, or the fact it has 1 proton means it's hydrogen. But then the mass number of these 3 isotopes change. So the problem in the book says the following table gives the number of protons, neutrons, and of nuclei of various atoms. First question is, when is the atom an isotope of atom A? Okay, so in order to be an isotope, what has to be the same? Is it the number of neutrons or the number of protons? And the answer is number of protons. So looking at atom A, what other atom has the same number of protons as atom A? And the answer is atom D with 32. Which atom has the same mass number as atom A? Well, the first thing I have to do is I have to find the mass number. So I'm going to take 32 plus 39 and I get 71. I do this 33 plus 38, get 71. 38 plus 50 gives me 88. And 32 plus 38 gives me 70. So which two have the same mass number? Okay, and the answers are A and B. And what is the identity? I added this question. It's not part of the book question. It says, what's the identity of all the elements? So for this, I'm just going to look at the number of protons. So element number 32 is germanium. Element number 33 is arsenic. Element 38 is strontium. And element 32 is also germanium. So you see that these two have the same atomic symbols. All right, number 46 says naturally occurring nitrogen is a mixture of nitrogen 14 and nitrogen 15. Give the number of protons, neutrons, and electrons in the neutral atom of each isotope. So again, set up a table where I have the protons, neutrons, and electrons, and the two nuclei. Okay. Because this is nitrogen, I should be able to look at the periodic table and tell what the number of protons are. Because this is nitrogen, the atomic number is 7. Okay. The neutrons simply is the 14 minus the 7 to give me 7. And it says here that it's a neutral atom. And so, therefore, the number of protons has to equal the number of electrons at 7. Looking at nitrogen 15, it's still nitrogen, so it's still 7 protons. But now, when I take 15 minus 7, I end up with 8 neutrons. And when I look at the because it's a neutral atom, again, it still needs to have 7 electrons. And that is the end of section 2.3.